This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to the show, Tanmai.
Hey, everybody. Hey, Jeff. Thanks for having me.
Absolutely. Glad you're here. So let's dive right in. What is GraphQL and why should our listeners know more about it?
That's a question. So let me. I have layers of answers for that question. So let me start with what GraphQL is, right? So GraphQL is an API specification similar to the way REST is an API specification, similar to the way SOAP was an API was a SOAP an API specification. Exactly. SQL to a degree is another kind of API specification, right? So GraphQL is just another API specification where it's intended for and optimized for a few particular use cases, but at its core, it's an API specification. Now, this was an API specification that got developed at Facebook in the last decade, and then they open sourced it around 2016 as developers kind of started really enjoying it and liking it and taking to it. There was the creation of the GraphQL Foundation, which was a part of the Linux Foundation within the CNCF. And we're also founding members and a bunch of early adopters, some early vendors in the ecosystem all kind of came together and founded that GraphQL Foundation to help govern the specification and help it evolve over the coming years. So that at its core is what GraphQL is. It's an API specification. Now, we'll talk about why this API specification exists and why people are excited about it, and why you should also be excited about it as a listener. So now, kind of it sits the same layer as an API specification as where HTTP and REST APIs do for this kind of use case that you have when front-endish applications are talking to back-end APIs, right? It sits at that layer. It was intended to sit at that layer. You can use any API specification for doing anything, so you can obviously do that, but that's kind of where it started off. So where it started off was when you load the Facebook application, you use the Facebook app after you log in. Maybe you're on your news feed and you're looking at your news feed, right? That API call that's getting that news feed started using GraphQL queries, right? And that's kind of evolved there. And today also, when you see kind of GraphQL being used in most places, people are using it for as a better API specification for their applications to talk to their backend systems. Now, when you think about this API and think about kind of what happens when you use this API, put yourself in the shoes of this application developer or the team that's writing these API calls to fetch data from the backend, essentially, or to make API calls to fetch API results, right, and render that on your application. When you're doing that, you run into a few kind of common challenges that are very irritating as a developer. So if you think about like this challenge of you're rendering a screen, maybe it's an e-commerce application, right, and you want to show the profile of this user, right? And so you're showing the profile of this user, of the end user, that has the name, email, stuff like that. It has their last 5 addresses. It has their recent transactions, right? Maybe a bunch of other relevant information that you want to have for this user on their profile page. Now, if you're building this application out, you'll realize that to service this application, you'll have to make multiple API calls to fetch this, because just the way that the ecosystem has panned out and the way the industry has shaped up is that there is an API development team that builds APIs and gives them to you. And because it's a different team, you have to talk to them to get APIs, and they build APIs, right? So there's obviously, because it's a different team, it's a different set of humans, they're building API endpoints and giving them to you. And so when you get to this time of building this application, this profile screen, you're looking at a different API endpoint for a profile, like you're fetching the username, and then you're hitting a different API endpoint for their transactions. You're hitting a different API endpoint for their last 5 credit cards, right? So you're hitting these different API endpoints.
Ah, yes, the endless problem of endpoint proliferation.
Exactly, right? And so as an application developer, like you're making these API calls, you're integrating them, and you run into all sorts of these problems that you don't want to solve, right? Like you're like, man, if this API returns in 100 milliseconds and then this one returns in 500 milliseconds and then this one is really flaky, how do I get them to render at the same time? Do I block all rendering, right? Or do I wait for it to incrementally render? Because that's the nature of this, right? You can run into problems like that. You'll often run into problems where you're like, man, this profile endpoint returns 100 attributes. I don't want to get 100 attributes. This is a mobile screen. I just need to show username and email.
Right.
I don't need these 100 properties of this user. Why are we eating up the network? Like, it's slower, it's expensive. Why are we doing that if I just want to show username and email, right? And then now all of these problems are solvable. For example, You can go and talk to the API development team and say, can you give me an endpoint that is just exactly what I need for my screen? But like humans don't like talking to each other, right? Like clearly, you've seen that happen all across the world.
Or even if they do, it doesn't necessarily mean communication is happening.
Exactly. People are talking at each other, right? So,
Yes.
so man, that got a little existential. But that this happens, right? You have this application development team, and they're like, give me a better API. And then it takes 6 weeks for you to give them a spec of what API you want, which is that one API that gets you all of the data that you want and only the data that you want. And then they build it and then they send it back to you. And we still haven't really solved API documentation, right? Everybody just sort of does it in a different way. They have different practices around it. Some people use open API specs, some people use a Google Sheet, some people use things like a Postman and share a collection with you of their API endpoints, right? Like there's just too many different ways of doing things, which means that this idea of like requesting this unique API endpoint and then somebody giving that endpoint to you and then documenting it, and like every time a tiny part of the shape changes or and then there's actual integration concerns about they didn't document the types properly, right? Maybe they're serializing it from Python and they used a weird library that returns a Boolean with a capital TRUE as a string instead of returning it as a JSON true that's serialized like as per the JSON specification. And you realize that error, like when you got the API endpoint, that's not how it was documented. Like death by 1,000 cuts for this is like, you don't want to worry about all of this, right? So GraphQL came up as a more coherent way of addressing these problems more systematically, right? And that kind of is where GraphQL started. Of course, there's like any new thing that you create, it's a new abstraction. There'll be more. There's things to think about. There's trade-offs and there's stuff like that. But that was kind of the setting or where the world was when we decided, or when the community kind of looked at, hey, GraphQL could be a really elegant way to solve these problems. But that's how GraphQL started.
So basically, to sum up some of the things you said previously, you could use any form of API specification to define APIs, as you mentioned before, but there's obviously trade-offs and pros and cons, which, as we know, as software engineers, it's all just trade-offs. But some of the trade-offs you mentioned are things like difficulty with consistent documentation and endpoint proliferation and difficulties of communication between front-end and back-end team, and then the need to have specific APIs, which sounds brittle and fragile. And so generally speaking, it seems like some smart people had this idea to say, what if we could take something more akin to what Martin Fowler calls a specification pattern, define search criteria on the client, and then enable the system that's responding to those client requests to apply those criteria on behalf of the client. Is that correct?
Exactly. Right. It's exactly like that. It's exactly kind of motivated with that sense in mind. And the reason why GraphQL became really popular with these developers, because it also hit upon an interesting thing that we have as developers today, is that the de facto kind of communication standard between systems has become JSON. And GraphQL is shamelessly all about the JSON. It's all about making it convenient to query that the set of endpoints that you have that respond with JSON, and for you to consume that JSON, right? And that experience is really, really nice of learning GraphQL and using GraphQL because it's about JSON, and that also has trade-offs when it comes to non-JSON information. But that's kind of what makes GraphQL really nice to use as well. And one of the big reasons behind why it became popular, as opposed to so many other ways of solving that problem with REST, with enhancements to REST, with conventions on top of REST, with entirely different solutions as well. That's one of the reasons why GraphQL also became really popular, because JSON was just becoming this de facto and is kind of like this de facto way of exchanging data between decoupled systems.
Yeah, that's really interesting. So I imagine as you're defining your GraphQL API, you mentioned documentation before, so I'm sure we'll get a little bit more into that as we go, but people need to know what they have access to. So talk a little bit about how you define your GraphQL API, and then can listeners read to it? I guess the answer is yes, but can they write to it? And let's explore those topics for a little bit.
That's one of the key things about GraphQL, right? And so let's take the analogy back to the REST world, where imagine that you're building a REST API endpoint, right? How would you build it? You would write a piece of code that is served over a web server, right? There's a path that it's attached to. When the path is called by a web server, it hits a function. We'll call that a controller, say. That function, it's a piece of code that executes some logic that returns some data in JSON, right? And the parameters are that you're taking it over a URL path, you're taking some URL parameters, maybe you're taking a JSON payload as some input. and perform some logic, and you return with some output, right? Now, GraphQL is a very, very similar idea. The idea is that now somebody sends you a query, the parameter is now a query, right? It's not a pass and like query params and a JSON payload. It's actually a query. So think of it as like I'm posting to this endpoint that says query user, user.id, user.email, right? So if you look at GraphQL, it kind of looks like the query that you're sending to the server is the JSON that you would want, but only the keys of the JSON that you would want. So imagine that the JSON that you wanted was a user object that had ID as a key, value, name as a key, and value. If that's the response you wanted, the query that you send is user, open brace, ID, comma, email, close brace. That's the query that you send. So you're sending it the skeleton of the response that you want. Now, the first thing the web server does when it receives this GraphQL query is that it maps fields that you see to functions. So it takes the user and it says, what function in my code can process this user field, right? And then the controller runs the logic of trying to get the user information and get only ID and email as responses, and then that function runs and decides what to do. So that's kind of broadly how GraphQL works. Nothing earth-shakingly different, right? It's just defining a pattern for how you would take that query, map it to different functions that you have. So when you think about GraphQL and you have user.transactions, user.savecards, it's essentially calling these functions in like a depth first search way, right? So you hit users, you call the user function. Then you call the transactions function. Then you call the savecards function. So you call these different functions, it returns the right bits of data, and then that becomes the final JSON, and that JSON gets sent out. Again, nothing particularly magical, just fairly straightforward.
Yeah, sounds very simple. Although later on, I'm sure we'll dig a little bit more into the N+1 problem that listeners are probably considering there.
Exactly.
So that kind of explains the reading side. Now, how about on the person building the GraphQL API? How do they go about actually defining the schemas that can service up these queries?
Yep, that's a very good question. So there's a variety of ways that you'll see in the ecosystem for how that final schema comes together. Originally, and this is the approach that Facebook took when they built GraphQL, they already had a lot of these functions that would return various entities, right? And so as they would build a new function, so if I built a transactions function, right, or I build a transactions model that is connected to the user's model, and I'm writing a function for being able to extract transactions or fetch that user's transactions, the act of me writing that function, that piece of code, would automatically create a GraphQL schema. So you're writing you're creating these entities, that define your API. And from that definition, and as you write them, the GraphQL schema kind of gets spit out automatically, right? And that GraphQL schema essentially contains it's your definition of there's users have this type, and then users have transactions, and transactions have 10 attributes, and safeguards have 100 attributes, and these are their different types and stuff like that, right? So that becomes the schema. The act of creating those functions or those controllers or those entities creates the schema. Within that also, there are many different approaches. You can go model first, you can go function first, right? There is then another popular approach, which is that you start with the GraphQL schema itself. So you start by saying, what do I want my schema to be? I want my schema to be users that has these 5 attributes and transactions and whatnot. So you define the schema first, and then you write each of those functions that are basically that back those schema, right? So you write, because you had a schema that had users, transactions, cards, you'll now have a function that has a users function, a transactions function, a cards function, right? The third approach is like a metadata approach, which is the approach that we take at Hasura, which is that you define the metadata it's a declarative way of defining what your different models are and how to access those models, what the sources of those models are. And then a system like Hasura automatically creates the GraphQL API for that definition of models, right? So you can have a variety of methods just like you would for REST as well.
Yeah, that's interesting. As you're saying that now, I know if listeners are anything like me or some of them, they hear the word ORM and some of them run headed for the hills, and others can't imagine life without them. And so there's kind of a strong separation there, I think, in the community. Yep. I'm not sure if it's 50-50, but it's definitely strongly, separation there. And that does sound like a little bit like the metadata approach is approach. So I don't say that disparagingly, but it does have some relationship, I think. And so let's pause on that a little bit. When we get further into the show, I want to explore that a little bit more. So you've kind of now described how we send our queries, how we sort of define these models and the different ways of doing that, which is interesting. API first, metadata, these sorts of things, defining your functions. So that's all the reading side. Now, if I have a REST API, I could make a read-only REST API, but it's often useful to be able to do things with my REST API as well.
Yep.
So let's talk about, can you write to GraphQL? Could you always write to GraphQL? And can you now? Let's explore that a little bit.
Yep, that's a very good question. And it's often something that people don't think about when they think about GraphQL, because they're like, hey, 90% of my workload is read. GraphQL is great for reads. Let me just use it for reads. But of course, GraphQL also has a story for writes, and GraphQL calls them mutations. Now, when you look at the RESTish or RESTful kind of conventions, you use HTTP verbs, right? So you'd say get a resource, and then you'd have a post endpoint, which is the idea of being able to go in and create something, right? You have put to go in and replace something. You have delete, and you have these different kind of HTTP verbs with different endpoints and different payloads that you use as kind of a loose convention to define what you want to do. Now, it's just a convention is important to remember, right? You could also technically have a get endpoint that's actually writing data. Don't do that.
Yes, don't do that.
Don't do that, but you could, right? Because it's just ultimately just strings and a convention, right?
Although you can't send it a body, so you'd be getting all that from the query string, which is even more gross, but I digress.
Yeah, exactly. But I mean, so technically you could get it from the body, but again, don't do that. Like, don't write a web server that for a get endpoint peeks into the payload, right? Because you should not be expecting a payload, right? So with GraphQL, the idea was that we just have one endpoint, and typically people implement it as a post endpoint that will take a GraphQL query and process it. Now, when I send a GraphQL query that describes the skeleton shape I was talking about, that becomes a read query. In that payload, when I start that query, instead of using the word query, if I started with the word mutation, that then defines that I'm doing a write kind of activity. So I'm doing something that will mutate state potentially. GraphQL says the GraphQL convention is you use queries for the query keyword, which is reading, and mutation for the mutation. The mutation keyword is that you want to write stuff. Now, that mutation could be insert, update, delete. It could do a bunch of things. We don't care about a more granular specification. We only care about the fact that it's a mutation. And the way a mutation gets represented in GraphQL is also pretty straightforward. The way, for example, a create user mutation would look like, you'd say mutation, and then you open up a brace and say create user, and then you specify all the arguments that you want for create user. So you'd say create user name is name, name key value pair, email key value pair, right? Those are the arguments to your create user. And the output that you expect after that mutation is you expect the new ID. Maybe you want to read the username again. Maybe you want to read the email again. So ID, username, email, social handles, any enrichment that you did, right? You want to expect that as the output. So in the GraphQL world, you're using mutations to specify these kind of arguments that you want to do for write. And then you're reading back after the write. You're reading back stuff and you're expecting a JSON payload. And you use the same kind of idea that I'm going to specify the keys that I care about in that response. And so you specify those keys. So you say create user, name, email, and in the response, I want only ID. So it's create user, name, email, open curly brace, ID. And that's your mutation. Now, the convention that you would create for your own API is you would have mutation create user, mutation delete user, mutation update user. But all of those create, update, insert words it's your API.
Right. These aren't verbs that are defined.
Exactly. Exactly. GraphQL only says mutation and then steps back and lets you define your convention. So you want to have a CRUDish style thing where it's insert, update, delete, up to you. You want to have something that's more like actions, right? Where each word represents more of a domain concept that might happen, right? Like create new user, right? Which is less CRUD and more an action that happens, right? More like a CQRS type thing. Like it's a command that you're you're invoking a command. And that command can do many things, right? It's not a CRUDish thing necessarily. So that's your convention basically now.
Okay. So we can read, we can write, we can define schemas. And it sounds like, too, this gets us closer to, I'll have to find the article that I read recently that talked about how the internet is built on what's called the narrow waist. And it really boils down to, it's just text. It's just text over TCP. Of course, now they're moving to text over UDP with HTTP3. And in a similar way, that's where I think REST APIs have struggled, because they take away a lot of that narrow waist and they add a lot of conventions that aren't always followed. And then there's conventions on conventions and all these things. And as Jim Morris said, the wonderful thing about standards is there's so many of them to choose from. And so it feels like that's sort of where we've gotten with the REST-ish type APIs. Whereas with GraphQL, it sounds like it's closer to that narrow waist where it's query and mutation, it's JSON in, it's JSON out.
Yep, that's it.
Fantastic.
Right? And that makes it very nice. I just wanted to add one more thing, Jeff, that queries also, GraphQL also support subscriptions, which is interesting. So the three keywords in GraphQL are query, mutation, and subscription. So subscription is the idea of being able to, it's like query, but you're looking at events or you're looking at real-time information that is typically coming in over WebSockets. But so those are the three kind of keywords that GraphQL has. And then whatever you want for your domain is the convention that you can have inside those three keywords.
Interesting. And I would imagine not every GraphQL implementation necessarily supports all of these, like subscriptions, for example.
Exactly. Exactly. Some GraphQL APIs won't support mutations. They'll only do queries.
Right. Now with subscription, let's talk about that a little bit more because that's new to me and it might be new to some listeners as well. Subscription sounds a bit like a kind of like a pub sub subscribe.
Yep. That's it's meant for those kinds of use cases. The idea is that you might be having a chat application. You might have an API that is requesting a stream of data. You might be subscribing to a particular comment and watch like live emojis happen on that comment, for example, right? These are kind of situations where you're looking at data coming in as it comes in from the server and is sent to the client. Data that is coming in from the server as it is sent to the client. Now here you'll see that typically people would want to do this over WebSockets. If you were implementing this with REST yourself, you can do a lot. There's a lot of variation possible with how you would structure that, right? Set up a WebSocket client, set up a WebSocket server, the protocol that you want to have for authentication, authorization, how you're going to exchange information. There's a lot to work with there. With GraphQL subscriptions, you still use WebSockets, but because there's a GraphQL specification, the consumption of these real-time events or data becomes easy on the client side. And because you're just using a normal GraphQL client and you say, subscribe to user name. And so if username changes, you'll change that on your thing, right? Or you'll say, subscribe to messages on this channel. And as messages come in, it'll fire like a hook on your client side or something, and then you'll render them as it comes in, right? And that just becomes a nicer integration experience. You still have to do the hard work of having a GraphQL server that can actually fetch data from a stream, that can do the authorization work. You still need to build that part out, but at least from a protocol point of view, from the client and server setup point of view, some of that has been standardized and has been taken away from kind of what you have to worry about. But you still have to do the hard work of doing the pub sub.
Yeah, well, and that's what a good abstraction does, is it puts the hard work where it belongs, which is on the person shipping the API and not on the person integrating with the API.
Exactly.
We've explored a lot of topics about how you define your schemas with GraphQL, the fact that it can read, it can write. You can even have subscriptions. We're talking about queries, mutations, and subscription. What kind of things would you put a GraphQL API on top of?
That's a really good question. You can put a GraphQL API on top of anything. If you're willing to do the work of building the code that can not just kind of process the query, but understand from processing the query how to actually go fetch the data from various sources, right? So if you're willing to do that work, you could put a GraphQL API on anything that you want, right? So for example, you can build your own GraphQL API, but you can also put your GraphQL API on nothing, right? Just like an API, it can be a GraphQL API that literally just creates data out of code, right? It's like randomly creating some data and sending some data to you.
Like a fake API just for testing the API surface area. Yeah,
exactly, right? You can have a GraphQL API that does that. You can have a GraphQL API that ultimately goes and talks to a database, like a Postgres database or any relational database. You can put it on top of a NoSQL database or a Graph database, right? Anything that's actually a backing store of data. I recently, over the weekend, implemented a GraphQL API that lets you query your operating system. So I can do query processes, UID, process name, right? So statistics about the process.
Yeah, but in my Z shell, I've got PS AUX. Like, what do I need? No, I'm kidding. That's actually really cool. That's really cool.
Yeah, exactly. So, but what you just said is the crux of it. You already have PSAUX pipe through grep and do whatever you want.
Yeah.
So why would you build a GraphQL API, which is exactly the question that you should be asking? Do I need to be sticking a GraphQL API on top of this thing? And I think that's really the crux of it, right? It's like there are two big reasons to want to do that. The first is You have a bunch of application developers at what I call the edge, right? You have developers who are increasingly building applications at the edge. Now, the edge is kind of just this evolution of mobile, web, serverless, workers, right? Stuff that is kind of happening in a different security context and a different performance context from where the rest of your centralized kind of data and logic is, right? It's the decentralized data and logic processing part of your business.
Right.
Now, those developers, when they want access to stuff, like you said, the narrow waist is HTTP, the narrow waist is JSON, right? Give them that access over GraphQL and they love you for it. For example, if you were building an application that showed you a web UI that showed you what processes were running on, your data center or machine for whatever reason, right? Now, they would want it over JSON, right? Like you wouldn't want them to send in CLI console commands or whatever on a screen and then get that response as STD out text and then have the browser process it. You might as well send it over HTTP and you might as well have a JSON query language for sending the payload and getting the responses. And that makes for an easier experience all the way around. So whenever you kind of start reaching those scenarios where people want to consume these APIs, especially at the edge, GraphQL becomes a really nice way of exposing that data, right? And then you can decide what to stick GraphQL on top of.
Okay. So like anything else we mentioned before, there's trade-offs, and you've kind of touched a little bit on some use cases that GraphQL can be useful for, but let's dive a little bit into some of the trade-offs, because the risk with any new tool is people treat it as the tool. And then, the next thing you know, we've got some of the problems that we tend to have in the software industry repeating themselves over and over again.
Yep.
And of course, we all know what the definition of insanity is in that context. So as we talk about trade-offs and use cases, let's talk about first performance and caching. So
for sure,
obviously, performance is one of those things where people always say performance, but obviously it's a concern here, and listeners might wonder, like, well, I know how to build REST APIs, I know how to make the performance. So how do I deal with performance and caching in a GraphQL context?
Yeah, that's a really good question. I would say that the fundamental source of the trade-offs in GraphQL is that we flipped control of what data is being fetched to the client, right? You're in a REST world, you as the API developer decide what data your consumer is going to get. In the GraphQL world, the GraphQL client decides what data they want to fetch. Now, this is, in a sense, the root cause of all trade-offs. All of the cons and the complexities of GraphQL come from, all of the pros of GraphQL also come from that, which is that the client can decide what they want. But, all the cons also come from that fundamental decision that the client decides. So when we talk about performance and caching, as soon as you let the client decide what data they want to get from these APIs, or 100 API endpoints, and they would have had 100 different API endpoints, but now they've coalesced it into one query, and now they're getting that data. The challenge for performance is, because you don't know what data the client wants upfront, you might have very inefficient ways of fetching that data, because you don't know what data you want upfront. For example, if I knew that you want user and transactions upfront, I can make a really optimized query to the database or to whatever source I have to fetch exactly users and transactions, right? I'll do a join because I know that my database can handle these joins very well. Or I won't do a join if I know that my database can't handle joins very well. Or if it's a geo-distributed database, I'll shard it appropriately. I'll know what to do, right? Because I know the shape of the data that you want upfront. But as soon as I don't know what data you want, because you can do user.transactions, you can do user.transactions, user.safeguards. Now I have to make sure that this backend system that I'm building, I'm able to fetch the various sources that I have as optimally as possible and kind of create an optimal query plan and create an optimal data fetching route. Now, there are many different ways of approaching this. For example, the approach that we've taken, and this is what we'll see in the industry as well, is we've segmented it into 3 different categories of how you can optimize for this kind of data fetching. If you know that this data is coming from the same source, you execute a different kind of plan, which is more oriented around doing joins and doing JSON aggregations in the same source. If you know that the data is coming from 2 different data sources, which are 2 databases, you can employ techniques that are similar to what people have done in the data virtualization space, where they've said, how do I take this one SQL query that's actually fetching data from 2 places? How do I create temporary tables, do efficient joins across databases to kind of fetch data? And then the third is when you have 2 entirely disparate systems. You have a REST API that's giving you users, and you have a database that's giving you transactions, or another REST API that's giving you transactions. So what you do here is This has been called the data loader pattern by the GraphQL industry, which is that you do memoization or per request caching. So there are different kind of approaches that you can take depending on how you're fetching data from where. So that's kind of on the data fetching side. Does that make sense?
It does. And it reminds me a bit of how relational databases have a query planner. And in this case, It does sound a bit like you're having to do some of the query planning, especially when you're dealing with disparate data sources. Because at that point, unless somebody comes up with this technology, and maybe, Hasura is going to do this to somebody, but anyway, somebody have to come up with some abstraction that allows you to do that. And let's not even worry about that for now, because that sounds pretty crazy.
Exactly. And on the caching front, it's fairly similar, where the existing caching infrastructure does break down when it comes to GraphQL, because what we kind of assumed as an industry, as a convention, was that we'll use get for fetching data. And so what happens is that everything, like your CDNs, your cloud infrastructure, your clients, everybody kind of respects the fact that, your cache get results potentially. And you'll have cache headers on them, and you'll have these get endpoints, and they'll be cached at various layers, right? So potentially, when you're making a request, you might not even be hitting the final database or the final web server. That response might come in from one of those layers in the middle, whether it's a CDN, it's a varnish cache, it's a Redis thing, whatever it is, because that's been the convention. Now with GraphQL, that becomes a little bit hairy, because your infrastructure in the middle has to be changed to understand that you're going to be potentially caching post requests because you're sending a query payload, right? Or you have to, before you ship GraphQL to production, you want to make sure that you getify all your queries. So instead of doing a post and a query endpoint, you do something like a get endpoint, and you send it a query hash, like an identifier of the query. And the server has a pre-registered list of queries that the client has registered, and it's able to service that. So you leverage your get infrastructure. But it's one of the things that people are building and figuring out, and having different approaches to server-side caching.
Well, that's interesting too, because what you just described there, that puts still the power in the hands of the client of which queries they're going to send.
Exactly.
But if they pre-register those queries, now they can simplify what they have to. And of course, I'd recommend, as I always do, you create an SDK for this API, so they're not having to do all this manually.
Exactly.
And then the hash just gets flowed automatically, and they don't have to worry about the hash.
Exactly.
But the beauty of that now is too, now your system team is able to say which queries have been registered, and they can do some checks and pre-optimizations and these sorts of things, instead of, we're going to get some random query we don't know about. So now you kind of, this basically is, now that communication is going to happen, and it's going to happen asynchronously, and it's going to happen automatically between the systems instead of between the people.
Exactly. Right. And that is a recommended best practice, especially if you're building applications where you know those query structures as you're building the application. Now, this doesn't work in those scenarios where the API surface area is meant to be dynamic, right? Like, for example, your product is an API. You're a business. The API is a product that you sell to developers who are outside your organization, and they're doing something else with it. Maybe they're building services with it. They're ingesting that. Maybe they're building applications, but you don't own it.
You don't know.
In those cases, you do want to give them a flexible API and let them query for whatever they want. And so when you think about how to cache and you think about security kind of things, you have to have different ways of thinking about it, right? Maybe you have like an execution quota, right, that they get on the kinds of queries they can run. You get like 500 milliseconds to the minute. You get 500 milliseconds of query execution time every minute. So, make a complex query, make a simple query, but you have 500 milliseconds of execution time. So that could become the security paradigm that you want to have when you do want to expose a dynamic API.
Okay, good to know. Well, again, more trade-offs.
Exactly.
And that kind of leads a little bit now into security approaches and implications. So, for example, which user is calling this API? And maybe there's certain properties like personally identifying information or credit card numbers or passwords, which I don't know. I'm like, should you really put the credit card number in a get from a GraphQL API? But that, whatever. But certain information where maybe certain people can access it and certain people can't, or certain systems can access it, other systems can't. So how does GraphQL kind of approach the security implications of who can see what?
Yeah, that's a very good question. The short answer is GraphQL doesn't care. So GraphQL says, you do security. We give you an API specification that lets you define how you want to fetch data, how you're mutating stuff, how you're subscribing to stuff. You do security the way you need to. So it ends up essentially, I think, breaking down into the common layers that you would have to when you think about API security. Anyway, You think about what I call authorization, which is who gets access to what entities. And then exactly what you were saying, Jeff, you then have a layer of authorization, which then defines, like, for example, the first layer of authorization is I'm trying to fetch this account. Can I even access this account model? Yes, I'm the account owner or the account manager. So I do get access to this account.
Mm-hmm.
The second layer of authorization is what fields do I see on that model, right? Do I get to see the fields vanilla as they are? Do I see all the 100 attributes of the model? Do I see only 50? And then for some of them, do I see derived version of that? Maybe I see a token instead of the credit card number,
Right?
I just get last 4 digits. I don't get the whole number. So maybe I'm getting transformations or hidden properties of that. So there's kind of that aspect of security, which is authorization. Then there's kind of the authentication aspect of security, which is typically handled outside the GraphQL server, maybe at your API gateway layer or something like that, that knows how to process JWT tokens or cookies and convert them into session information that your GraphQL server can then handle and inject into its authorization, right? So that when the GraphQL server gets a query for users, it can convert it to a select star from user where user ID equal to session ID, right? And it can do that, but the authentication piece is done by the API gateway. And then the third piece, which is unique to GraphQL, that as an ecosystem, we're still trying to figure out what are different ways of approaching that, are the typical kind of API security practices that you would have wanted to have, which are a little bit outside strictly authentication or authorization. And these are things like rate limits, slow loris attacks, WebSocket attacks, right? Denial of service issues, distributed denial of service issues, large like response payload issues, right?
Yeah.
Either during request responses, like those kinds of things that are kind of at that very front of the API, kind of your API stack. It's the edge of your API stack, which will frequently have to contend with these problems. Now, most of it you can apply techniques that you would have had from just your REST world. They would have to have a little bit of modification because you're breaking some conventions around get and post and stuff like that. You're posting queries for reading and writing. So you have to evolve that a little bit from a logging and monitoring point of view of knowing that there are security breaches or events. You might want to evolve that infrastructure a little bit. I think most of it works with that evolution. The part of it that I've always found very interesting is query complexity or rate limiting based on complexity, which I find just like a fascinating space to think about, which is that you are giving people a dynamic surface area to query on. You can't use your usual ways of thinking about rate limits, which is 100 API calls per minute, because that sort of doesn't make sense, right? Because it's not, we don't know what the API endpoint is. We want to give that control to the user. So how do we create a nicer rate limiting abstraction that works for this kind of flexibility in GraphQL? So I think that's kind of a place which is new, but everything else sort of works.
Yeah, and that's challenging too, because I could think of, you could have a request that returns essentially one record. I know I'm thinking relationally, and we're talking JSON, but you could have request returns one record, but the cost could be incredibly high.
Exactly.
And so you might want to rate limit by cost. And of course, relational databases have query planners and cost calculations and these sorts of things, which are all different, but the idea is there. But REST API, REST-ish APIs, they don't have that notion. And then of course you want to limit by total amount of content or maybe how deep the structured graph is.
Exactly.
So that definitely sounds like a very interesting challenge.
Yep. And it's like one of those things where REST is easier in those respects, because when you've created that REST endpoint that returns one record, but it's very expensive, you know that it's expensive.
Yes.
So because you know that it's expensive, you can assign a static rate limit to it. But when that same record is a part of a GraphQL API query, somebody might be fetching just that record. Somebody might be fetching that record with other things, right? Now you might want to have different rate limits when it's a part of a thing or it's independently fetched. That becomes complicated.
That's right. And you're shifting the complexity down to the system behind the API, which is the right thing to do because that's technical empathy for your end user, but that does also bring new challenges and trade-offs.
Exactly.
Which
I
think leads us to a good next topic, which is to avoid the GraphQL all the things approach that people might try to do. When is GraphQL not the right solution?
Yeah, I think today there's a pretty simple answer to that, which is that GraphQL is not a good solution if your data is not JSON.
Okay.
So if your data is video data, binary data, file data, right, and it's not JSON, that's just immediate cutout for GraphQL. GraphQL is not a good fit. But apart from that, there would be some use cases also where I'd say that GraphQL might not be a phenomenal fit. For example, if you have an extremely write-heavy workload, right, you're pushing stuff continuously into a pipe. For example, say you have IoT devices that are continuously emitting data, right? You have systems that are emitting logs that are just writing into something and you're not really reading, you don't have a read load, GraphQL is overkill at that point, right?
Don't use mutate for that, I think is what you're saying. That's not the...
Yeah, I mean, yeah, because if your API is 90% mutate and 10% query, you lose the benefits of GraphQL because GraphQL was designed to optimize the query path.
Yes.
It was designed to handle the mutate path, but it wasn't really optimized for the mutation experience. It was optimized for the query experience, right? And so if you just have a 90-10 kind of split, then you don't have to use GraphQL, right? And you might benefit from not using GraphQL and using a format that is more efficient because there's interesting trade-offs with write-heavy workloads, right? It's a different subset of use cases. So I would say broadly, I would say those are the two places where GraphQL might not be a good fit. Things that are not JSON and things that are very write-heavy.
Now, how about internal versus external APIs? I think you could get the impression that this is a way to deliver APIs for application developers, but are there use cases where it makes sense to actually provide a GraphQL API for internal consumption between systems?
That's a very good question. I would say, I think there's no reason you can't do it for sure. So when it comes to like this integration between systems, it depends on what you're optimizing for. Let's say, for example, the different systems that are talking to each other, right, are talking to each other in the same kind of security context, right? And the same, they're all running kind of in the same kind of cloud infrastructure. There's no kind of security implication to what they're doing. There's very little network latency between these two systems. They can be chatty, right? For example, you have a server in the same region as another server, and these two processes can kind of just talk to each other, and they can afford to be chatty, right? In those cases, you might benefit from more kind of chatty protocols where there's back and forth that's continuously happening. Something like a gRPC might be more beneficial, right? But if these two services that are talking to each other, these two systems that are talking to each other cannot afford to be chatty, which basically boils down to two reasons. It boils down to either because there's a switch in security context, right? If the security contexts are different, they can't really chat with each other as if they write co-located, right? You can't have frequent back and forth communication because you're continuously changing the security context. And the second is if there's a performance implication, which is that there are two services, but they're two services, like one is running on a Cloudflare worker and one is running in your like AWS centralized EC2 infrastructure, right? They are two processes, yes, but there is speed of light issues. They're far away from each other, right?
Yes.
So in those contexts, now GraphQL can become better because GraphQL allows you to be less chatty more elegantly, right? It says, well, clearly you can't be very chatty in this context. You do want to fetch a certain amount of data. Why don't you as a client decide what data you want to fetch? So here developers are kind of making more precise API calls to fetch the information that they want because they want to control the amount of data that they send. They want to make sure that the security check is optimized and they're not triggering 100 security checks unnecessarily, right? In a chatty protocol, every record that you'd fetch, you'd want to do a security check. Don't do that if you're very chatty, right? Like, It's better to put them closer together and let them talk in an unbounded security context with just each other. So I think it's those kinds of constraints. So I would say when it's service to service communication, the way I like to think about it is GraphQL is a great fit when you have centralized systems talking to decentralized systems, right? That's where GraphQL is the perfect fit. If you have two systems within the centralized area or two systems within the decentralized area, I wouldn't reach for GraphQL, right? But when you're going from like centralized to edge, GraphQL is a great fit. Edge to edge, centralized, maybe not.
And I would add to that, I think the same could be said of REST-ish APIs as well, where when those are used for internal service-to-service communications, it sometimes makes me go a little bit crazy. But when you're using those for external, it starts to make a lot more sense. But I digress.
Exactly. And because the internal external is also very interesting in what you said. Sometimes you could have internal applications, right? So that's different too.
Yes, that's correct. And sometimes you have systems of systems, and there's neat reasons to encapsulate things in various ways. And so again, it's all trade-offs.
Exactly.
There is no, this is always the right answer in this case, but there are good practices that we can follow as you're helping us understand. So I imagine with GraphQL, somebody could, just like with the web, they could create their own web server and come up with their own implementations of all of the standards, again, the constraints and the verbs and everything like that. And similarly, somebody could do the same with GraphQL. But I imagine there's been a tooling ecosystem that has grown up around GraphQL. So Maybe share with us a little bit about the different approaches to tooling around GraphQL and what listeners can expect as they start looking for tooling in the GraphQL ecosystem.
It's very similar to what you would expect in an API ecosystem. You have client-side tooling, you have server-side tooling, and then you have collaboration tooling, right? Those are the categories that I would put it. So I would call it client-side tools, server-side tools, and you could call it SDLC tooling, you could call it collaboration tooling, right? So those are the three categories in which you'll find tooling for GraphQL within the GraphQL ecosystem. So you'll have popular GraphQL clients. What GraphQL clients do is they integrate really well with your application development kind of environment. Maybe it's web, maybe it's mobile, maybe it's a Java service that you're writing. So different languages, different devices or platforms that you're running on. You'll have clients that can basically auto-generate the SDK that you were talking about, Jeff, right? Like having an SDK experience for an API is amazing. One of the big wins for GraphQL is that GraphQL clients automate that SDK experience. You can literally, like while you're building a web application or you're building something that talks to a GraphQL API, you can just do a SDK.generate or call a CLI command that like generates the SDK on demand. So it takes the GraphQL schema and it generates a typed SDK that integrates really well with your language. And then you can just, with your application development kind of language and environment, and then works with that. So you'll see a set of tools there. You'll see a bunch of tools on the GraphQL server side. These are things that help you build GraphQL servers. The work that we're doing at Hasura is kind of in that one category of tooling that helps you build different GraphQL services. And there's, again, many different approaches. There's GraphQL as a service kind of tools. There's GraphQL server tools that help you literally build GraphQL servers from scratch and tooling there. And then, of course, there's collaboration tools that are basically API collaboration tools for GraphQL. Your GraphQL schema is changing and you want to see how the GraphQL schema changes. You make commits to your Git repository. You want to trigger certain things that verify whether the GraphQL schema has evolved in a way that might break the schema, like you removed a field from the user, right? And it'll do an automated check. So there's the kind of this SDLC tooling as well. So those are the three broad categories of tooling that you'll see in the GraphQL ecosystem. The GraphQL ecosystem tooling on the monitoring and like what I would say the ops front has been slower to catch up. So it is there, and typically that category of tools, the monitoring and observability and caching side, is starting to grow gradually. You'll see that kind of tooling integrated a little bit with the people who are and the community members or vendors who are building things on the GraphQL server side. So the GraphQL server tools try to also solve for some of those ops problems within the kind of the ambit of that GraphQL server tool. So we notice that. Hopefully over time we start seeing that separate out a little more, with things like OpenTelemetry and whatnot, and GraphQL specific OpenTelemetry and stuff like that.
And that makes sense too, as we talked before about things like query planning and handling, complex queries, the ability to monitor and say, hey, again, it does sound very similar to what relational databases had to do. But the difference is instead of it being in a monolithic database server or even in a sharded, cluster of database servers, now we're moving the same problem up, but there's similar challenges. And so you need this ability to monitor, see what's going on, observe what's going on. And even if you're getting expensive queries, proactively consider ways that you might be able to optimize and deliver improvements before the end user, the consumer, even complains about it.
Exactly.
Yeah. Okay. Well, let's talk some about the Hasura solution then. What makes Hasura unique in the GraphQL ecosystem? You mentioned a little bit before that your focus is on the server tooling side of things. So talk a little bit about Hasura specifically and why it exists and what it accomplishes for people who are interested in using GraphQL.
Very similar to kind of some of the themes that we've been discussing. I think our aim with Hasura is to make sure that people get kind of the benefits of GraphQL without having to do some of the heavy lifting that you have to do when you're building your own GraphQL ecosystem. So the way Hasura kind of thinks about it is, what is the fastest way that we can get you from these different data sources that you have to a production-ready GraphQL API, right? So instead of taking hours or days per API endpoint, we want to do it in like 60 seconds, right? You go from 100 models across 4 different data sources to an API within a few days, as opposed to kind of wiring everything up and setting that up in an effort that might take weeks and months to kind of take to production, secure, add monitoring around it and stuff like that. So that's kind of where Hasura sits. It takes a metadata approach to helping you model the various things that you have in different types of data sources and setting up the authorization rules. That's the most important piece of this, to make sure that Hasura has a policy engine that allows you to specify these authorization rules for each model, what fields are visible, what fields are hidden, what fields are PII, what entities can be read and why. Documents can be read if you're a collaborator or if you're an editor, or if the document is public, right? Those kinds of, that policy engine is what Hasura kind of absorbs. And then using that, Hasura presents a GraphQL API that has conventions around pagination, filtering, relationships, aggregation, streaming, live queries, CRUD style mutations, event triggers, a bunch of stuff that follows a common convention in how you'd like to typically interact with those set of models. So that's kind of where Hasura sits and how Hasura works.
And I will be very busy creating show notes for all of the things that you just mentioned so that listeners can go look those things up. You did mention Policy Engine. I'm curious if there's any relationship there to Open Policy Agent or if this is something Hasura specific.
This is something Hasura specific. I mean,
Okay.
it's open source, and we built the entire thing. We launched the open source engine in 2018. And so the Policy Engine is an open source engine. It's most similar to, I would say, for those of you familiar with databases, if you're familiar with the RLS engine in databases, row-level security engines that certain advanced relational databases have, it's that idea. It's that kind of flexibility and that idea that we've gotten to Hasura.
Okay. So looking at your website, I see instant real-time GraphQL API for PostgreSQL. So clearly there's some connection here with PostgreSQL as a supported data source for Hasura.
Yep.
But I imagine that's also not the only data source that Hasura supports. So explore a little bit for us why PostgreSQL is so prominently mentioned on your website, but then also what other data sources does Hasura support? Clearly the operating system is one, but I imagine there's others.
Yeah, no. So that's a great question. So when we started building Hasura, we built it only for Postgres because that was made sense to kind of choose Postgres as a emerging database. Postgres is also interesting, one of those databases that is now becoming almost an open specification of how a database should behave. And the underlying systems are different. If you're tracking the Postgres ecosystem, you'll see it's not just the core Postgres database that's become amazing, but you have so many offshoots of within the Postgres family, whether it's things like Yugabyte, Cockroach, new things like Neon.tech, which is like a serverless Postgres first offering, AWS Aurora, Google recently launched AlloyDB, which again is exact Postgres but optimized for ML, AI, and statistical workloads, right? So fascinating kind of work in the Postgres ecosystem. Made sense for us to kind of support Postgres as our first data source. But over the years, we've added support for SQL Server, for BigQuery, and we're now rapidly adding support for as many data sources as we can. One of the things we launched recently, along with our open source project, was what we call GraphQL Data Connector. It's an API and an SDK that allows any developer to build support for their own data source without waiting for Hasura to add support for it. And that's in the context of that is when I built out support for the operating system. So what I did was I spent an hour customizing or adding an agent to the back half of Hasura's query planning, authorization, compilation kind of engine, right? Hasura does all of that work. And at the final AST that I get, that is actually the query for a particular data source, I customize that last bit so that instead of hitting a database query SQL route or a REST API endpoint, I can then fetch whatever I want. And so I customize that bit to actually fetch from the operating system. And that's how I spend only like a few hours and I get support for the operating system. But the GraphQL API that I get is fully featured. Pagination, joins, authorization, caching, security, all of that taken care of. And I'm just customizing the last bit of that like pipeline to fetch that specific data that I want.
Well, you mentioned AST, which for listeners who didn't catch that, that's an abstract syntax tree, which if you've ever taken a compiler class in computer science programs, you know what that is. And essentially, that's another example of a wonderful abstraction because once you've compiled down to, which by the way, I mentioned Open Policy Agent before, its rules compile down to an AST that's actually represented in a JSON document because it's all JSON at the end. And so in a similar fashion, if you can look at this, a similar thing, the system.link in the .NET space, same thing, it compiles down to an AST.
Exactly.
And so that's really interesting that you're able to do that and really powerful. And so basically, from what you said, if Hasura doesn't already support a specific data source, if a listener wants to create a data source to pull from, then knock yourself out, go for it. Now, can they contribute those back in? Is there a contrib project or something on GitHub?
Yeah. Yeah, we've just started that. So you'll see it on our main GraphQL engine repo. It's just github.com/Hasura/GraphQL engine. The SDK, the connector SDK that we've released is in alpha right now. Towards the end of the year, I'm hoping that we have like a registry that is kind of a more formal place for people to kind of maintain and publish different versions of their connectors. Right now, it's just pull requests that you can put into the code repo and it'll go into a directory on our main thing. And over time, we'll have more governance around it.
Okay. And do you have examples on GitHub or on your site that demonstrate sort of when to use? Like, I imagine that in some cases, it makes sense for people to ship both REST-ish API endpoints as well as GraphQL endpoints side by side. So you have examples to kind of guide listeners in that area?
Yeah, we do. We talk about this quite a bit, especially in like harsher enterprise environments where you can't just switch API protocols immediately, right? That you have so many mission critical systems and so many teams where you want to do GraphQL and REST, you want to do a gradual transition, maybe you want to do both for a period of time. So several different examples kind of walking you through how you can set that up. One of the very interesting things that we built was an ability for you to create REST endpoints out of GraphQL instantly. So you create the GraphQL API first, you get this hyper flexible surface area. But then what you do is when you're working with specific API customers, clients, applications that prefer a REST API, you can bang out REST APIs really, really quickly. You create the GraphQL query and you name it, and that becomes a REST endpoint. So you're like, oh, here's a /user endpoint, and then that's backed by a particular GraphQL query.
Declarative REST API based on a GraphQL underpinning.
Spot on.
Very thin.
That's exactly it.
Yes. And less time writing controllers and actions and focusing on delivering business
what
value,
they want.
Which is a good thing.
Exactly. Right. And then that works with all of your REST infrastructure as well. So that works particularly well when you have a lot of investment on the ops side, on the infrastructure side, on the IT side, which is already around REST.
Right. So let's talk about deployment and integration with Hasura. I know that like a lot of open source projects, there's both a community edition and an enterprise edition. So maybe talk about the differences. And then, of course, self-hosted versus cloud-hosted. So maybe share with listeners as they want to get started, how can they get started on their own? And then what would cause them to want to move up to another level with either a hosted environment or an enterprise license?
No, that's a really good question. So the easiest way to try Hasura out is to just pull down the Docker container. If you have an existing data source, point that to the data source. Wherever you can run a container, you can run Hasura. It's stateless and clusters automatically so that you can run one instance, you can scale that out and run 100 different instances of Hasura. We're going to be publishing a benchmark that talks about our streaming subscriptions and scaling to 1 million streaming subscriptions with I think 70 instances of Hasura or something. And so you can kind of do that with Hasura containers. And exactly like Jeff said, you can run our managed cloud service where we run these for you in the VPC of your choice or in a multi-tenant environment on your cloud vendor. So that's kind of a managed service. You don't have to run Hasura, manage Hasura, scale it up or down, or customize it for workloads, and then you can run it yourself. Now, as you kind of move up various tiers on our cloud offering, or if you move from open source to a self-hosted enterprise version, what we want to ensure is that in a mission critical kind of deployment, the total cost of owning and delivering your API is as conveniently taken, is basically something that Hasura handles for you. So if you want to kind of look at enhanced API security, you want to look at certain methods of governance, you want to look at performance SLAs, and those are the kinds of features. You want to look at observability or monitoring integrations with your existing stack, right? Those are the kinds of features that are then available in our commercial versions so that, the build and the API experience is the same across both. You can switch back and forth between the two. But as soon as you come to kind of some of those investments on the DevOps, SDLC, and Ops side of things that you'd rather not bother with because it's necessary for your business, but you don't want to do it.
Right.
That's the part that Hasura automates for you.
Okay.
So you'll see that on our commercial versions.
And people can get started, and then they can grow up into either a cloud-hosted or a enterprise edition as the need arises.
Exactly. And there's a perpetual free tier on cloud as well. So, just sign up, point it to your thing, and you should be up and running in 30 seconds.
That's great. Docker compose up and, just here you go.
Exactly.
You're doing the GraphQL thing.
Exactly.
Anything else about Hasura or GraphQL that we've missed that you want to make sure listeners know about?
Just asking listeners to try Hasura out and give us feedback on what their experience with GraphQL and Hasura was like would be great. And to watch out for some of the new streaming subscriptions work that we're doing that allows people to stream billions of records over a GraphQL API for data-heavy APIs. That's going to be very exciting. That's something that we're going to be talking about soon.
Okay, very interesting. And if listeners want to find out more about what you're up to, where should they go?
Hasura.io is the best portal, the starting portal to go into the different universes. Active forums are our Discord forum, our GitHub forums. That's kind of where you can hang with other developers and other users, talk about where I should use Hasura, where I can use GraphQL, talk to the Hasura engineers itself. And of course, please always, at any point of time, feel free to reach out to me. I'm pretty responsive on Twitter and on LinkedIn.
Okay. And your Twitter is Tanmaigo, Tanmaigo on Twitter. And then also you blog at hasura.io. That's hasura.io/blog/@ Tanmaig, Tanmaig. Is that right?
Yep.
Okay, great.
That's perfect.
Well, Tanmai, thank you so much for joining us today on Software Engineering Radio. It was great having you.
Thank you so much for having me, Jeff. It was a great conversation.
Great. This is Jeff Doolittle for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.